Hi everyone, we are from Team Hobo Squad and my name is Yongshen.
My name is Kenneth.
My name is Hui Hong.
And we are here to present to you our IoT application which we have developed. It's called the AgriPie. AgriPie is a smart greenhouse soil moisture monitoring and irrigation system, and our target audience is towards organizations in the agriculture industry or anybody who wants a method of automation. So our main features is to be able to monitor plants via a responsive web application, monitor soil moisture level and water the plant automatically, as well as to monitor the access control of the greenhouse using an RFID sensor. We will also monitor a plant surrounding environment such as the humidity, the light value as well as the temperature level. We will also upload images of the plant as well as the greenhouse at a set interval to the web application. So moving on, our IoT application also has bonus features such as implementing a web application using EC2, using RFID system. We implemented an intermediate feature such as a soil moisture sensor, utilizing the pump with a motor, and we upload the camera photos to the web application, control the actuator using MQTT. So this is a view of our system architecture. The laptop will be running a server Pi, which is hosting using Flask, and it's hosted onto EC2 to control the 3 actuators for the 3 Pi, and it subscribes to the topping and displays the real-time data on the web application. For the Raspberry Pis, it consists of Greenhouse, Farm 1 as well as Farm 2. All 3 of them will be running environment.py to publish onto database to show the real-time values. It will also be running the chem.py. They will publish the data through Boto3 onto DynamoDB using Amazon Web Services. For Greenhouse, we'll be running RFID.py to log recent access entries. All these are publishing data to and fro to the DynamoDB. And for Farm 2, you will send a AWS SNS alert to the email and mobile through a subscription of the simple notification service. The IoT rule query statement consists of 6 IoT rules that is publishing and as well as subscribing using the Amazon Web Services. Okay, next I'll be talking about the hardware setup for all the 3 Raspberry Pis. All 3 Raspberry Pi will consist of similar things such as the LCD screen, DHT11 sensor, the light sensor with the MCP3008 ADC, Raspberry Pi camera, as well as buzzer. So for Greenhouse Raspberry Pi, is a bonus feature added using the RFID sensor, RFID cards. You'll also be using one red and green LED to showcase the actuators. For Farm 1, you'll be added a bonus feature of using the soil moisture sensor, the 5V relay channel module, as well as a submersible water pump for the irrigation system. For Farm 2, you'll be utilizing a soil moisture sensor to send data to the database and activate an SNS alert to the end user. Okay, now I will show you how our hardware setup looks like. So this is the greenhouse. The greenhouse consists of a breadboard which is connected to all the modules, including the RFID card as well as the camera. We have multiple RFID cards to track logs of the access. Now moving on, we have Farm 2 over here, which is set up to monitor the soil moisture level. Now over here is Farm 1, which tracks the soil moisture level. That's connected to the potted plant, and then there's a water pump as well. There's submerged in the water to pump water level if the water moisture level is dry.
Hi guys, so my name is Kenneth. I'll be demonstrating my contributions to our AgriPie project. So firstly, is the RFID where users are able to, so this is to monitor access control to the greenhouse. So for example, now if somebody was to tap it, you will hear a short buzz with a green LED. This would mean that the person has proper access to the greenhouse. But if the card was not detected properly, you will actually see a red LED with a very long buzz. So as you can, if you take a look at the website, you can actually see the latest, most recent login and the UID of the card that was used for the most recent login. Next, the next feature I will be showcasing is the Pi camera, actually laid out so that it is able to capture an image that includes the entire greenhouse. So if you take a look on the web application, there is actually a button for us to take a picture. So if we click that button, it will take a while for the picture to be taken and then uploaded. But once it is ready, it will actually update. As you can see, there was an update there. This feature is set so that it updates the picture every 30 seconds to ensure that there's for part of security. Next, environment of the greenhouse. We actually take, using the DHT sensor and the LDR, we are actually taking the real-time values of the greenhouse, as you can see here, and the historical value of the light, temperature, and humidity. Finally, we actually have a section, two buttons to actually control actuators. By clicking on, you will see that the LED for the greenhouse actually turns on, and when you click off, it will turn it off manually. So this will allow administrators or technicians to actually ensure that all of their hardwares are working, their LEDs and buzzers are working. Let me show you the buzzer now. So if you click on, the buzzer will sound, and then you can turn it off manually. So these are all the features for greenhouse.
Okay, so now I'll be showcasing to you the Farm 1 as well as its bonus feature, the soil moisture watering pump system. So as we can see over here, alright, we have a layout of the water pump. So the 5-volt relay, the soil moisture sensor which is planted towards the pot over here, and the water pump is a little bit above, so that when we activate the pump code, the water will be pumped into the plant. So right now I'll run the code so that it will detect the soil moisture level. So once the code has been run, it will detect whether the moisture level is whether it's wet or it's dry. So if it's dry, it will pump water at an interval of 0.3 sleep seconds so that it doesn't overflow, or if the flow is always constantly running. This is to prevent the soil from overwatering. So it will keep on repeating this loop until the soil that is detected will be wet. Once it's wet, it will stop the pump from flowing the water. So as the pump is still being activated, it will always publish the topic to dynamic DB. Over here at pump database, and it will always show an activate value over here as long as it's starting to pump water to the soil. The code will stop publishing the topic to the DynamoDB as long as the soil moisture is wet. So as we can see here now, the pot is filled with water. Okay, the pump has stopped pumping water to the soil, the potted plant. And we will see at the LCD over here, it says that the soil is wet, so the pump will be turned off. So this is a bonus feature that we have added for our IoT application. And then we can see on the web application, we have about the same layout as the greenhouse earlier. But right now I want to zoom in onto the taking of the photo. And once we place the picture, we take a photo, and it will update into the Boto3 database. And then we pull out the picture and publish it onto the web application so that we can see the real time of the state of the plant once this has been updated. Okay, it may take a little while because it's going to be published on the cloud. So this is the updated photo of the potted plant for Farm 1. Next, we're going to talk about the temperature reading. It's always updated at a real-time value. So if we zoom in on the temperature, you can see the date and time is being updated and the temperature reading, as well as the humidity level and the light sensor value. So right now we're going to display the actuator to be controlled, which is the pump. So if I were to switch on the pump manually, okay, the pump will pump water onto the spotted plant. But be aware that if you were to activate the pump, it may risk that the soil will be overflowed with water. So right now I'm going to demonstrate to you what it looks like when I switch on the pump manually. Okay, I'm going to press the button now. Zoom out a little bit. Okay, if I don't switch off the pump immediately, it's going to overflow, as you can see over here, and this is a risky feature, so do not turn this on if not needed.
Hi, so this is Farm 2. As you can see, it has a similar setup with Farm 1 with the soil moisture sensor. However, this setup doesn't have the pump. Instead, when the soil moisture detects that it's dry, it will send a SNS alert to the email to alert the owner that the plant is dry and is in need of water. So now to showcase the email sending. So when the soil moisture is dry, it will automatically send an SNS email alert to the owner to tell him that to alert him that the soil is dry. So moving on, the SNS alert also sends an SMS alert to the user's mobile phone. So next, Farm 2 also has a way to take picture of the plant, as seen here. So it's going to take a while before it uploads the image to the web application. And yeah, as you can see here, the date time value has been updated and the current image of the plant has been updated. The web application also has buttons to control the buzzer on the farm. As you can see, I will be pressing switch on, and there will be a small buzz there. Let me just try again. Then now to turn it off. So Farm 2 also has records environmental values such as temperature, humidity, light value, and displays its real-time history of the values recorded. Yeah.
Due to time constraint, there are so few features that our team could not be accomplished. So they are database to store proof RFID cards to check for authorized users, automatically remove captured images after uploading into the cloud. We got a live feed of the camera to monitor the real-time environment of the Raspberry Pi, as well as the farmhouse. The record live feed as a video file to a storage so that the administrator can check back for logging purposes. Okay, so to conclude, we believe that this IoT project will benefit the target audience and make their life easier by reducing their workload and by creating a smarter planting environment. Okay, so if you're interested to check out our project, our source code and tutorial is available at the GitHub. Here's a link stated at Kenneth Wang Yangqi and DSSM IoT AgriPi. So if you have any other further questions about our system, you can contact us at Siu Hong, Kenneth Wang or Yongshen at ichat.sp.edu.sg. Thank you.